Hello and welcome back to Mascumila Learning and Maski TV. We are here again with your very own teacher Tandi. Today, grade 7, we are going to go on and on and on, but we are still in our transformation, but we're focusing on the calculation of surface areas and volumes. While you're staying in there, hanging in there, we're going to just look into the objectives and what it is that we're going to, at the end of this lesson, make sure that we understand. We need to be able to distinguish between the volume and the surface area when we have the 3D shape. Remember, the 3D shape can be anything that you have, which you can be able to see more than one side on it. So if I have this book, you can see it has one side and another one there and another one there. So if you check, all these sides are actually two in one. So you can see there's one, which is the second one is that, and there's this one, the second one is that. The other side will have been the same with this other side. So this therefore will become your rectangular prism because it has rectangles all over the show, and if you put it down, then it's land down with its rectangle. Same applies to if you were having something like this. This is another kind of a prism we can call, and this is a cylinder which we don't use at this point. We have an ice cube, if you remember it. It's another 3D shape that you guys can know or what we have. Even the box itself, it is our 3D shape. And now we need to know how to then use those to calculate our surface area as well as the volumes, and where do we then apply those things. So if you look at this examples that we have put there, we are saying to you, put it on the chart and let us engage. Remember, math is a doing subject. We have to do it for us to know it. So when you're looking at this two, tell us what is the difference between these two sets. We have set A and set B. What is the difference between the two? Do you see any difference? And if yes, please pop into the chat. You can see that we do have our blue here, which is similar on the other side. So you can see, if you can be able to tell us what is this shape and what is that other shape and the other ones, and tell us the difference if you can on the chart, so that we can be able to do. In my own context, I know that this is what we call 2D shape, which is just our normal square, circle, rectangle, or any other polygon that we have. And the other set, which is our set B, that is what we call two-dimensional shape, three-dimensional shape. I mean to say this is two-dimensional shapes here. On your set A, that is your two-dimensional shape, and on your set B, that is your three-dimensional shape, which is what we see or what we use at home in most cases. All right, here is another example. So when you're calculating a volume, you can then use this, or maybe a volume or a surface area. So let's look at this productively. The volume is defined as the three-dimensional shape object, and is the amount of space that is occupied. So if you put water inside anything, be it a tin, be it a container, you put water in there, we then call that water a volume, or whatever that the water fills, we call that space volume. So that's how we get the volume, and volume therefore can then be calculated, or can be having the units with a cubic meter or cubic centimeter or cubic millimeter. So it has to be to the exponent 3. That is how we calculate the volume. And you can see here, for example, a cube is this shape here. If you look at it, there you can see there's many small cubes that we have there. So when we calculate the volume, we literally just say it is side multiplied by side multiplied by side. So that is how we get to a volume space, and that is our formula for when we are calculating the volume of a cube. But when you calculate the volume of a rectangular prism, which I've given an example there of a box, we then use the length, and we use the breadth, and then we use the height. Now you need to remember, where is the length and how do we know that that's the length? So this line that you see here, this is our length. These lines that we see here, they are literally the line that we call length. And then the line that we call height, therefore, will be the line that we see here. So you see my orange one here, this is literally going to be our height. And you can see that these lines are literally repeating on the other side where we cannot see. And then the breadth, therefore, will be this one. So if I had to label, this will be where my B is, and this will be where my height is, and that will be where my length is. Sorry, that will be where my length is. Let's label that properly. My length will be here, and then that will be where my height is. So that is how you then come up to say volume is therefore equals to length multiplied by breadth multiplied by height. And that's how we calculate the volume of the rectangular prism. Please bear in mind that this is very important for us to go forward. As for surface area, surface area simple means you have the areas and addition or the sum of all the areas that you have around the things. So suppose this box was unpacked. If you unpack the box, you should have all the 6 sides I showed you to say that we have the side here and we have the side at the bottom, which is the same as the one that is at the top here. We have this one here and we have another one on the other side, which is the same as the one that we have here. We have the side and this point, which is the same as the one that we will see that side. So for surface area, you literally just have to say I have 6 sides, and with these 6 sides, if I can then multiply them with my side squared, which is what we are saying in either a cube or in either a surface area, that is how, or the surface area of a rectangular prism. That's how we get it. So an example with a rectangular prism, since we said we have 6 of the sides, so let me show you. So we have one of the sides, which can be like this. So that is one of my 2D, but this is 2. We don't have one of them, we have times 2 of this. So it is on this side, on the top and at the bottom. So we literally have 2 of this. So if I was to calculate or to write down if I were to write down the area of this one, I would have to use my length and my breadth. So I would say area, which is our normal formula of the area, is equals to length multiplied by breadth. So you can see here I have that spot where I have the length multiplied by breadth. But that is if I was talking about one side, it will just be length times breadth. Because we said we have 2 of this same side, that means I'm going to multiply the whole of this by length multiplied by breadth again. So that means the area of these 2 sides will instead not just 1 but 2 multiplied by this 2. And that goes to all of the sides that we have. Even the smallest side that we are having there would have to go through the same thing. So I would have had my longest side, which is looking like this. If you check on my box, it looks something like that. So it also going to have the similar context of how we are multiplying. So I'll have my height there and I'll have my breadth there. So when I calculate that, I will be saying I have an area, which we said is 2 of them sideways. So I would have 2 multiplied by breadth multiplied by a height. So that's why you would see we then have a breadth times a height like that. So we add them together for us to go where we want to go. So these are the 2 sides that we have, and this other side that we are having, therefore you can see is our biggest or the longest side there. So if I then draw that in this context, please don't mind my drawing. Since you are using a ruler, you should be able to draw this in a very, very good way. Mine don't have a ruler, so it takes me a little bit of a while to get it right. So with this one, then I will have my length still, but there is my height. So to calculate or to write down the area there, I would have area to be equals to 2, because these sides are also 2. So it's 2 multiplied by a length times height. So these 3 areas would have been added together for us to end up with the surface area as it is shown in this slide. All right, I hope you guys have understood that. And you can now be able to use it to apply it to use the concept. So let's see. If I have to then calculate the volume, as I've indicated, we need to use this formulas here. You can see that we are saying a cube is something like this, which I gave an example of an ice cube, and also another cubes that we have. It's a three-dimensional shape as well, and it has 6 faces with 12 edges. One will be like, what is the edges? So these points that we have here, they are called edges. So this is what we call edges all over and all around that particular shape. So you need to just count them and you see how many they are, and then how many corners we have. So you can see that we do have 8 corners as it said there. So it's more like we have the vertices in the space where the angle should have been. And then the volume is calculated. As I said, we use the sides of what we have and we cube that. So it's side multiplied by side multiplied by side. Because each side of a cube, it is literally called S, which represent the sides, or any other form that they can give you. All right, and that also apply when you are calculating for the surface area. You just take your 6 sides and then you multiply by the area. The area of a cube is always written as S times S, which is the same as S squared. So that's why here we have 6 multiplied by S squared. What is 6? The sides that we have in the cube, they're literally going to be 6 if you add or you look at them together like that. Okay, so let's get into some calculations while we are still on this. If I'm looking for a surface area and I'm given a point whereby I was told that one side is equal to 4 centimeters, and I'm looking for a volume, remember that volume is equals to side multiplied by a side multiplied by a side, which we call it side cubed, right? So if I have to just substitute, remember the cube have equal sides. So that means I have 4 multiplied by 4 multiplied by 4, and you can see that's how it's written there with 5 centimeters. This is then to guide you to say if I multiply this, I am going to end up with a cube there. So as much as you practice, you're going to be able to get to that point. So 4 times 4 times 4 gives us 64 centimeters cubed. You do not always just say centimeters. You only say centimeters if the unit that they've given you is indeed centimeters. If they give you meters, you must use meter cube. If they give you millimeters, you must use millimeters cube. All right, so please don't confuse them. It's not always the case where you just have to say it is centimeters. Okay, when you're looking for surface area as well, we usually just call it SA, just to summarize the word surface area. So we said surface area of a cube, it's 6 multiplied by S squared, which is the area. So that means we have 6 multiplied by 4 squared. If you use your calculator and calculate that, you will see that it gives you 96 centimeter squared. Why squared? Because if you multiply, then you multiply your centimeter that is there, which is coming with the 4. If I have my 4 centimeters and I multiply it with the 4 centimeters, the centimeter and the centimeter will give me a centimeter square. So that is why you will see then that we have that 4 squared, which will give then now 16 centimeters squared. If you multiply that by a 6, that is where you're going to have your 96 centimeters squared. Please always remember that each and every time they give you a unit, you have to follow that unit to solve the problem. Let's look at this one. This is a rectangular prism whereby you are given a rectangular prism, which you call it a cuboid, right? It's a 3D shape with 6 rectangular faces as indicated. So you can see when you're looking for volume, you actually use a length, you use width, which we call breadth. So please don't be confused. If you see width just in your mind, just also use the word breadth. So it can be width or it can be called breadth. So every time you see width, just remember that we have been talking about breadth. So this can be called breadth as well as width. Okay, so those are the two things that I wanted to show you in terms of what language that is used to determine the size that we have. Okay, let's quickly look at this example before we forget why we are trying to do what we are trying to do. So here, for example, if you are given this cuboid, you can see it's a cuboid, it's a rectangular prism because it does not have equal sides. So we have our length being equals to 10, we have our height being equals to 6, we have our breadth or width being equals to 4. So if ever we have to find a volume, remember that our volume, according to our formulas that we have been checking, it is actually equals to length multiplied by a height multiplied by a breadth or a width, whichever you prefer to say. So that will be 10 centimeters multiplied by our height is 6 centimeters multiplied by our breadth is 4 centimeters. So you can just calculate that together and then you'll be able to find your answer as quick as possible. So that is how you actually get your volume. And in this case, I have found my volume to be 240 centimeters cubed. And that's how you get to the volume in this case. As well as the surface area. If I were to be finding surface area, I would then have to do the similar thing in surface area. To calculate the surface area, remember that we said that you add all the things that you have and as all the surface area or the areas that we have in the space until you get. So here you can see that it's our length and our breadth, and you can see that this one is going to be our length multiplied by our height, and this one is going to be our breadth multiplied by our height. But all of this is multiplied by 2. If you multiply that together, then you can be able to see how we got to the answer, which is what is given to us. Oh, okay, I just saw this one. We have made one mistake. Remember we said centimeters will multiply. So centimeter times centimeter give us centimeter squared. Multiply it again, that will give us a cubed. So that should be a centimeters cubed. All right, so that is how it should look like. Same applies to the SA, which is our surface area. So if you use that volume and then you multiply together, you should be able to get 115,200, and that is in centimeters squared. It's not in centimeter cube. Remember, the volume is a centimeter cube, or it's a unit cubed, and the surface area is that unit squared. All right, so that is how we work out these things, and we have looked into one of our very favorable or very nice textbook that I really like when I'm in grade 7 space. It really have been aligned and make sure that grade 7 learner cannot go wrong without. So this is our very own Spot On. This book is very nice. So if you go into Spot On, into page 151, you will see many of this kind of questions. If you have it, please take it and let's work out this together. So I want you to just try and write those solution for those questions down, and then I will see you right after the break. Stay tuned. Okay, as I said, this is my one and only book that I've used today. So let's go through it together and answer the questions. The first question says, name the 3-dimension of 3D object. So you need to name the 3-dimension of any 3D object. Can you guys pop that on the chart so that we can be able to get that fine together? And the second one say, how many faces are there to a rectangular prism? We have talked about this. You guys should be able to remember that. Remember, I showed you that as well. So I need you guys to pop the answers on the chart so that we can be able to do that. So name the 3-dimension of a 3D shape. Name the 3-dimension of the 3D shape. You need to be able to do that, and then we can just remember on this space where we were working here. I literally have went down and show you what dimension that I use into the 3D shapes. So these are what we have talked about, and you just have to remember that those are also called dimensions. So the 3 dimensions that are there can be a height, a length, and a breadth. So remember, a breadth, I said it can also be called the width. So let's write them down. We have length, we have height, and we have breadth, right? Which we can also call the width. Remember, this one is a breadth, or it is a width. Right, so any of that can be what you have to do to respond to that question. Then the next one, then they said, how many faces are there to a rectangular prism? I'm actually holding a rectangular prism here. You can just remember how many faces. So these are the faces. What you see is what the face is all about. So you can just count them. And in my context, I see that 6 faces, or there are 6 faces. So you just have to literally just count them and then write them down. Calculate the surface area, right, of the following 3D object. So we are given a cube where the length of this cube is actually 2 centimeters. So what you need to do, right, is to remember what is the formula of the cube. That's 1 for you to calculate the surface area. So you just have to remember that the surface area should be equal to 6 multiplied by all the areas that you have. So that means you have 6 multiplied by 2 squared. So that is how you then multiply that out quickly, and then you get to the answer. So that will be 6 literally multiplied by 4, and that should be our 24. What was the unit? Centimeters. So 24 centimeter squared. That is the surface area. To cut the meters shorter, if you see there in number 2, the question was saying calculate the surface area. We went and added calculating of the volume if you check at the bottom on number 4. So you can parallelly respond to those two together. But let's see how far we can go. In number B, what was that? They said a rectangular prism where the length is 5. So we are still calculating the surface area, but we have the length of 5, the breadth, which is 4 centimeters, and the height, which is 3 centimeters. So what are we going to do? Write a surface area equals to 6. Remember, their formula is length multiplied by breadth plus length multiplied by height plus breadth multiplied by, I think we left 1, breadth multiplied by height, like that. So that is how we can write the formula down and just quickly substitute. The length is 5 multiplied by the breadth is 4. So we can do that. Let's add. I'm going to use a bigger bracket so that I can see where I'm going. Then the other one is length, which is 5. My height is 3. All right, let's add the last one. My breadth is 4 and my height is 3. So multiply that together. Remember, I have put 2 brackets because there's 6 outside that I need to deal with. If you multiply this together, they should be able to give you the answer as quickly as possible. So let me try to do that. It is 6 multiplied by 5 times 4, which is 20, plus 5 times 3, which is 15, and plus, what is the last one? 4 times 3, which is 12. Then I am going to multiply that by 6, and it gives me 282. Remember, it's a surface area, so it's centimeters squared because it's a surface area. So that is how you then deal with this question, and you can also do the same, recording the formula of the, you can see that in number 3, we are saying you must record the formula that the volume can use in the rectangular prism as well as the cube of that same thing. So you can then now in number 3 just record, but you can see that number 3 and number 4 need you to just work concurrently together. So if you can find the volume or record the volume of your rectangle, so we said volume is equals to what? How do we calculate the volume? So the volume will just be length multiplied by height multiplied by breadth or width. That is how we calculate the volume of a rectangular prism. So that literally will be our number B, while the number A, which is the cubic one, we will look at it later. So the volume of the rectangular prism, so I'm just saying VR, then you can remember. It will be length, which our length is 5 centimeters. Multiply that with our height, which is 3 centimeters, and our breadth, which is 4 centimeters. Multiply this together, and then you get your answer. Let's quickly do that. That is going to be 5 times 3 times 4. That should be 60, if I'm not mistaken. Let me just quickly check. That is 5 times 3 times 4. Yes, of course, that is 60 centimeters cubed because of it is a volume. Then the other one is the volume of a cube. I'm going to say VC, so we can remember that the volume of a cube. And the volume of a cube, it is therefore multiply. It's a side multiplied by a side multiplied by a side, which we write as S cubed. So that means we have 2 multiplied by a 2 multiplied by the 2, which then gives us 8. So that will be 8 centimeters cube as well. So that is how you would have responded and nailed these questions in this manner. So that is how you would have solved those questions that is given to us. But since we have a lot of questions that we literally need you guys to do, learn and be able to answer to these questions all the time, I just have realized now that it looks like each and every cube is basically 2 centimeter cubes, which is making it a bit funny, but it can be any number. Please don't be in the space where you think only the 2 centimeter cube is for one that we use for cubes. That is not the 2 centimeters. We can use any other number. So here they were saying, what is the surface area of this S cube? Easy, right? So now we know surface area will be equals to 6 multiplied by S squared, which means it's 6 multiplied by 2 squared, which means it's 6 times 4, which will still give us our 24 centimeters squared. That is our surface area. Right. So if you check here, you can see that this is one of the questions that it can come for your examination and you need to be able to answer it. This one, I have put it this way because I want you guys to then go to our platinum book in page 139, and you're able to calculate this in here. A hint for that is that you need to just take note that not all the units or the dimensions are having the same unit. So I want you to use this grid here and then convert them in such a way that you'll end up with one unit for all the dimensions. So if you check in all these two which I've put here, the dimensions does not have the same units. You need to convert it to one same unit, and then you use it. What is that unit? Which one is the unit we are talking about? They did tell us that they want us to have the nearest centimeter cube. So please go and change it to be in that manner, and make sure that you can answer these questions, because it's not difficult. It's very easy for us to answer them, but I need you guys to just go to our Platinum textbooks, and you are able to get that. As soon as you get into trouble, please ask us anywhere where you can possibly reach us. You can also just keep your hands, head, and everything you got into Masky TV. Subscribe, and make sure you like, share with your friends. Ensure that you are always alerted in what next, what's new, what are we bringing next, so that you can be able to learn more and share with others. Also, remember to ask Masky. If you get stuck, Masky will always be able to assist you. The number is 072-091-0388. Masky TV is your home of learning. We'll see you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.